Hello, hello. All right, this video we're going to be introducing vectors as applied practically to physics. This is what we did the first Monday after the Unit 1 test. And I'm going to work through the same problem that we did in class, so if you need to take a second look at it, this should help. Okay, so first off, some basics. Every vector can be drawn as an arrow or as an angle. Okay? So if this is the initial velocity vector of an arrow that we're firing, it has some known initial velocity. That vector has to have a horizontal component and it has to have a vertical component. So horizontal and a vertical. Now the thing about horizontal and vertical lines is that 100% of the time, horizontal and vertical lines will intersect at a right angle. Okay, so if we know this angle here is, and that's going to be theta. Theta is a known angle most of the time. Sometimes it's what you're looking for, but it's the variable we use to represent angle. So at some known angle, at some known initial velocity, our arrow is fired. From that, we can calculate its initial horizontal velocity and its initial vertical velocity. How fast it's rising, as well as how fast it's traveling to the side initially. To do that, we have to use trigonometry. Okay, so there are only two functions that you're actually allowed to use applied to a triangle. Okay, our three trigonometric functions are sine, cosine, and tangent. Now, when we use these, we're usually using them in reference to a right triangle. Now, there is a whole calculus explanation about what these things actually mean. You don't need to know that for today. All you need to know is that the sine of theta is equal to opposite over hypotenuse, and the cosine of theta is equal to adjacent over hypotenuse. There is also an equation for tangent, but I'm not going to tell you it because I don't want you to use it. Okay, because it lies to you half the time that you use it. So we just don't mess with it in here. The only time you should use it is here. I'll erase that. The tangent of theta is equal to the sine of theta divided by the cosine of theta. And that is an equation that will be more helpful for you in Unit 4 than it will be in Unit 3. We might use it a little bit when we do our vector addition lab 3.2, but other than that, you're not really going to use this equation very much. You'll be using these two a lot more. Now, I guess the first thing we need to talk about is what the heck are O, A, and H? Well, they stand for opposite, adjacent, and hypotenuse. They refer to sides of the triangle. The hypotenuse should be pretty obvious. The hypotenuse is always going to be the longest side, the side opposite the 90 degree. Okay, opposite and adjacent are relative to the known angle theta. So if we look at this triangle, we have three angles and three legs, or three sides. Every side is opposite an angle. So for our known angle, the leg that is opposite it is going to be O. So in this case, our vertical leg is the opposite leg. Okay, adjacent shares a side or shares an angle with, I had it right the first time. Shares a side with the known angle. So this is the adjacent leg. This is the angle. So they share this side. So then if we are going to try and break this vector up into its components, the vertical component would be called v naught y, and the horizontal component is called v naught x. So opposite is v naught y, adjacent is v naught x, and the hypotenuse refers to v naught, which is the initial velocity that we know. So let's say that we want to calculate v naught y. Okay, to do that, we first have to identify which of these two functions we want to use. Well, v naught y is the opposite leg, so we want to use the function that has o in it. So we are going to start with the sine of theta is equal to o over h. O and h are just placeholders. They can mean just about anything. It depends on what's happening in this triangle. In this triangle, h is v naught. And o is v naught y. So then the sine of theta is equal to v naught y divided by v naught. So to actually get v naught y, we would multiply by v naught. So v naught times the sine of theta gives us v naught y. Now we can run through the algebra, or you can just remember that the other leg is always the other function. So since v naught y used sine, v naught x is the same equation, it just uses cosine instead. So v naught times the cosine of theta will give us v naught x. So calculate v naught x and v naught y. Follow sig fig rules. If I tell you that v naught is 49.5 meters per second and theta is 35. Using this angle 35 and this initial velocity 49.5, calculate v naught x and v naught y. Pause the video while you do because I am about to walk through it. Actually, I'm just going to pause this, find the answer so that this video isn't even longer. Magic, I'm on the other side now. Okay, so we would use this equation because 49.5 is v naught and theta is 35. So if we multiply this out and we plug it into our calculator, we get this. I don't know if you can see that, but I think there it is. Okay, so 28.395 blah, blah, blah. We can only have 2 sig figs in our number because of the 35 in theta. So since we can only have 2 sig figs, we round this number to 2 sig figs. So 28.39 becomes 29. So as this arrow is going, its initial upward velocity, it is rising with an initial velocity of 29 meters per second instead of almost 50. There it is. Okay, we do the same thing for our horizontal velocity, except that we're going to use cosine, which I wrote improperly. I'm realizing this is cosine, not sine. My phone's just going to keep making noises because I'm recording. So we just plug in cosine instead, and this time we get this number. Same restriction, we have to have 2 sig figs, so 40.2 becomes 40. And that is how to break one up. That's how you would take a vector and break it into its horizontal and vertical components. Okay, I challenge you now to answer this problem. Oh, tell me my mouse is in the wrong spot. Okay, hang on. Okay, I want you to solve this problem. My finger's in the wrong spot. Okay, a plane flies 57.00 degrees west of north at a speed of 74.0 meters per second. How quickly is it moving north? Pause this video, take a crack at this problem, and then I'm going to work it out here in just a second. I'm also about to erase all of this work, so pause it now. Okay, the first thing we have to identify in this problem is what direction the plane is going. So first off, when it says west of north, north is your starting point. So we're traveling north, but we're traveling west of north. So you see how that angle I'm moving my hand through? This is north, we're traveling west of north. This angle is the angle that we know. So this has to be our 57.00. While the actual initial velocity is going to be along this arrow that it gave us. So 74.0 meters per second. And this is V. So we turn this into a triangle. If we bring this over here, we have a vector in this direction, and its vertical leg is north, and its horizontal leg is to the west. So here's our right angle. This is our known angle theta, and then we just have a velocity because it's traveling at a constant speed. So our equations then will be using our trig. This is our known angle, so this is opposite, this is adjacent, and this is the hypotenuse. So we are looking for the north leg. We want to know how fast it is traveling north. So we want the north leg, or the vertical leg of this problem. So we are looking for adjacent. We don't care about the horizontal. We're only looking for the adjacent. So then adjacent is cosine. So the cosine of theta is equal to A over H. A is going to be the velocity north, while O would be the velocity west. So the velocity north divided by the velocity. So then same thing, we're looking for V north, so we're going to solve this for V north. So V north is equal to V times the cosine of theta. Stop, period. I sounded like I was going on. That's it. That's the whole equation. So then we plug in our numbers. V is 74.0 times the cosine of 57.00. And if we plug that into our calculator, 74 times cosine 57.00 equals that comes out, get the glare off, to 40.3035, blah, blah, blah. We need 3 sig figs in our answer because our initial velocity only had 3. So we have 3 here, we have 4 here, so we have to ignore that 4th one. So we drop 1 off, we end up with 3 digits. So 3 digits, that's going to be 40, that's 3, 40.3 meters per second. And then I'm going to move this because the actual answer would be 40, can't write, 40.3 meters per second north. Technically, we have to include the direction. And that is it. If you have any questions, comment on the video or send me a message. This should be enough for you to start on the Chapter 3 homework. That is not necessarily a priority, but it might be worth trying to knock out some of the easier problems real quick before we start doing labs, because you're not going to have as much time to work on homework once the labs start. So that's it for this video. Hope this helps.